Hello everyone. In this video, we cover deferred insurance. Consider an n-year deferred insurance of one issued on a person at age X. The insurer pays $1 at the end of the year of death if the person dies only after age X plus N. Let Z be the present value random variable for this insurance. For n-year deferred insurance, if the person dies before reaching age X plus N, there's no death benefit. Therefore, in order to get the $1 death benefit at the end of the year of death, the person must first survive up to age X plus N. The corresponding probability is NPX. And then if the person dies within the 1 year before reaching age X plus N plus 1, corresponds to the event Kx equals N. The $1 death benefit is payable at this time point. The present value is nu to the power N plus 1. And the probability of the death benefit of 1 at this time point is NPX times Qx plus N. And if this is an n-year deferred life insurance, then the death benefit will be paid at the end of the year of death whenever the individual dies. The corresponding PMF is given as this. Kx less than or equals N minus 1, there's no death benefit. If Kx is greater than or equals N, the corresponding present value is nu to the power Kx plus 1. The expected value, we have the notation N bar AX. The N bar is the n-year deferred period, and AX corresponds to life insurance. We have this expression, and we have the corresponding formula for the variance of Z. The second moment of the n-year deferred insurance, we have the P superscript 2 and then N bar AX. Just evaluate N bar AX by replacing delta with 2 delta. Then we get this expression, the second moment. And then minus the square of N bar AX, we get the variance of Z. Let's take a look at some relationship. Here we consider the n-year deferred insurance. There's no benefit between age X and age X plus N. And then the death benefit of 1 is paid at the end of the year of death afterwards. Consider a life insurance issued on age X. The death benefit is paid after age X. And then consider the n-year term insurance. The death benefit is paid if the person dies between age X and age X plus N. From this two stream of death benefit payment, we can see that the n-year deferred insurance N by AX equals AX, the life insurance, minus the n-year term insurance. Or we can consider life insurance at age X plus N, and then discount back to age X using the actuarial present value factor, UN NPX. We establish another relationship, N bar AX equals UN NPX times AX plus N. And the expression UN times NPX is simply the pure endowment NEX. So we get this expression. Okay, now we consider the n-year deferred J-year term insurance. Similar definition. A death benefit of 1 is paid at the end of the year of death if the person dies after age X plus N, but before reaching age X plus N plus J. Let Z be the present value random variable for this insurance. A death benefit of 1 is paid if the person dies after age X plus N, before age X plus N plus J. So we get this stream of death benefit payment. And this is the EMF. And then the corresponding expectation, the notation, N bar, and then the J-year term insurance. And we get this expression. It varies from K equals N to K equals N plus J minus 1. And the corresponding expression for the variance of Z. We can establish a similar set of relationship for the N-year deferred J-year term insurance. This is the payment stream for the N-year deferred J-year term insurance. There's no death benefit if the person dies between age X and age X plus N. And then consider an N plus J year term insurance and the N year term insurance. We can get the relationship. Or consider a J year term insurance at age X plus N and then discount back. We get this expression. All right, so this is the set of formulas we have covered up to here. So you can see a similar set of expression between the N-year deferred insurance and N-year deferred J-year term insurance. Okay, so let's take a look at an example. For a 2-year deferred 2-year term insurance of 800 on a person selected at age 50, you are given that the death benefit is payable at the end of the year of death. The mortality follows the given table. This is a 3-year select and ultimate mortality table. The interest rate is 0.1. Calculate the actuarial present value of this insurance. All right, let's take a look at the solution. This is a 2-year deferred 2-year term insurance. So starting at age 50, the deferred period is until age 52. If the person dies before reaching age 52, there's no death benefit. And then the 2-year term insurance until age 54. The person is selected at age 50, and we have a 3-year select and ultimate table. So the age notation, we have the square bracket 50, and then the square bracket 50 plus 1, the square bracket 50 plus 2. And then for age 53 and 54, we follow the ultimate table. A death benefit of 800 if the person dies between age 52 and age 53. The corresponding present value is 800 and then times 1 over 1 plus I is 0.1 raised to the power 3. Discount back to age 50, the current age. The probability, we have 2P50 times Q50 plus 2. From the table, we can get the values. 1 minus Q50 times 1 minus Q50 plus 1, and then times Q50 plus 2. The corresponding value for the Qs, 0.19, 0.21, and 0.23. Substitute into the expression for the probabilities. We get this expression. And similarly, if the person dies between age 53 and age 54, the present value is 800 and then u to the power 4. The probability, 3P50 times Q53. And we get this expression. The actuarial present value of this insurance, simply add up these two expressions. The notation for this insurance, we can write it as 800 and then times this, the 2-year deferred period 2 bar, and then 2-year term insurance, A50 colon angle 2. This is a term insurance, the one above the age 50. And here, because the age is at selected age, so this notation should be square bracket 50. And then we get the answer, 155.77. That's it for today's video. Thank you for watching and see you in the next video.